First video of the new year. Mr. G Math coming at you live, right? 7202?
Yeah.
I'm hoping that for New Year you made a resolution.
Oh, I did.
What was the time is an existence of humans, so there shouldn't be any.
You know what? I want you to make it like this second semester. If you're going to make one commitment, that the second semester, your senior year, is your best academic semester out of anything you've done so far in high school. To make that commitment. 'Cause you know what's easy? For it to be your best social semester ever in high school. That's easy, right? What's difficult is to make it your best academic semester ever in high school, right? This second semester, senior, that's when you drop off a cliff or you rise up. And there's usually nothing in the middle. So that's the commitment I would like you to make. This one, wherever you're at, this will be your best semester academically ever. This one. And then go into college. Let's read this one together. Differential equations are equations with derivatives in them. In this course, you will only learn how to solve the simplest type of DiffEqs. Remember I said there's a whole semester course on this? This is just scratching the surface. You can sit there. In which you can separate variables. You may be asked to find a general solution of the differential equation, which gives you a family of curves, or a particular solution, which just gives you one single curve. So, this is like a little recipe we're going to follow today. So what's the procedure for solving a DiffEq? First, we're going to write y prime as dy by dx. So when you see y prime, they're equivalent to each other. But a real key here is to separate the y's and the x's. So when we go dy by dx, we can separate y and x rather than seeing it as y prime. So if you're given dy by dx, great. If it's y prime, change y prime to dy by dx. Now, multiply both sides of the equation by dx, meaning you have dy on one side and you have dx on the other side. Separate the variables. This is the most crucial step. What does that mean? All the y's on one side, all the x's on the other side. Integrate both sides of the equation. Solve for y if necessary, meaning if y isn't by itself, you might have to do some steps to undo whatever's around y to get it by itself. And if you're given an initial condition, I know, purple thing, then you can use what's given to actually have a specific solution that won't have a big C in it or anything like that. So let's practice together. Thankfully, you're going to have time to actually work on your assignment too that we can work on. Okay? So let's look at number one. Number one says, find a general solution of x plus 2y times y prime equals 0. And then first rewrite it as this and then so on. So guess what? The first step is, can you identify the y prime? What should you write that as? Let's do that. Let's see if this pen is not going to behave. Maybe this will work. So there's step one. Substitute dy by dx in for y prime. Step two. What does it say to do? Multiply everything by dx. So if I multiply everything by dx, it's no longer going to be in the denominator, and that means algebraically I can manipulate it better. So I want you to multiply everything by dx. So in this case, dx times x, we're going to put them in order, is x dx. Dx times this, well, the dx and the denominator dx, they actually divide out and leave you with 2y dy. And then 0 times dx is just 0. Next step, separate the variables. So that means on one side will be 2y dy, And then what can I simply do to bring the x's to the other side to separate them? Instead of adding, I can subtract. Next step is to integrate both sides. Both of these are simple power rules. What is the power rule for integration? Do you know? It's been a while, right? You know this scares me, right? 2.5 weeks of not me, right? Where are you at? What exponent is on the y right now that you don't see? What's the rule? Add 1. So now it's what? Good. And then what do you do? And 2 divided by 2? It's just 1y squared. And how can you know if you did it correctly? What's the derivative of y squared? Good. On the other side, what's the integration of negative x? What exponent don't you see? 1. What do I do with it? And then what do I do? Could you write that as 1/2 in front? Yes. Means the same thing. And then what can't we forget? How do I solve for y here? Square root both sides. So what's the answer? One answer. You know that there's 2 answers here? One's positive, the square root of negative x squared over 2 plus c. And the other is a negative in front of the square root sign.
So when you integrate, it gets rid of the dy and the dx?
That's right. I'll make it that simple. I won't go further than that. Yes. So when you integrate, it does get rid of the dx and dy. The dx and dy is connected to derivative, right? And when you integrate and it's derivative, it undoes derivative. Can we be that simple?
Yeah.
They undo each other. And that's it. Those are the 2 solutions that you have. Those are the general solutions. This one is actually not a function. So we have to separate it into 2 functions to describe the whole curve. If I gave a point, you'd have to be aware. Is the point that you're given have a positive y-coordinate or a negative y-coordinate? And that determines whether it's the first one or the bottom one. Did you hear what I said? We're going to do an example where you have to find a specific equation. That means you're going to be given a point. And what do you look at that point is the y-coordinate. If the y-coordinate's positive, which one would you use? The top one. If the y-coordinate was negative, which one would you use? The bottom one. See, altogether, this does not make a function. It would fail the vertical line test. But you can separate it into 2 functions rather than one complete. Okay, let's look at example number 2. Oh, and even, do you see this below? Really, that's where they wanted you to fill in what we already did. It is awkward. So, the work that we already did, I know some of you want to fill in that packet. There you go. All right, let's look at example number 2. It says, find an equation of a function which contains a point 0 and negative 3. Again, one of the things I'm going to focus in on is that the y-coordinate is... Are you paying attention to me? No, I know you are. Are you? And Miss Carmenita, are you? Okay, what did I just say? And it's on video.
No, I wasn't.
Oh, good. Honesty is good. I focus on the y-coordinate. Is it positive or negative? Because chances are there might be 2 different diffie-q's, right? We need to make sure we focus on the one that has a negative in front, right, in terms of doing it. Because if you're given a point, your end answer will not have a C in it. Okay, so we're going to find an equation using that point whose slope is this for each point x, y. Slope in calculus means, nope, Derivative. So slope means derivative. So in other words, I can write down dy by dx equals that. Step 1 is done. What does step 2 say? Both sides by dx. The more comfortable you are with diffie-qs, the more you can do 2 steps at once. In other words, not only do you multiply everything by dx, but you can also separate the variables, and you can do it in 1 step, right? Once you get more comfortable. Because what's the next step after that? It's to separate the variables. Do you notice that x and y are on the same side? How do I get the y's on one side and the x's on the other side? Both sides by y. Good. So we wrote the derivative as dy by dx, and then we separate the variables. Yes? Okay. What do I do next? Beautiful. Go for it. And why do I integrate? Gardy? Yeah, because it undoes the derivative, right? Or get rid of it, if you like. It sounds very mathy. You just get rid of it. Are you waiting for me?
No.
Can you integrate y? Remember what to focus on. The exponent. Focus. What's the exponent on y? What's the rule? Yes? I know. Good times. Barranco Casino. X times e to the x squared. How do I integrate that? That should be my saying, right? The Morongo's like good times always. And it should totally be my classroom, right? Room 7202. Good times always. Yeah. Okay. So let me tell you. I could just tell you, right? But can anyone tell me how to integrate x times e to the x squared? So the hook, in this case, is in the exponent. In fact, if you want to think of u and u prime, u is e to something. So do you see the e to the x squared? That's your u. Your u prime, the hook, right, is what's the derivative of x squared? All right, I'm going to write it that way. I'm going to write down 2x e to the x squared. So the derivative of x squared is 2x, and if I write it this way, the hook for the exponent is there. Once the hook is there, I just use the rule for e to integrate, which is the easiest rule of all. Now, what do I need to do to undo that to make sure they're equivalent? I need a 1/2 in front, right? That keeps them the same. I know we're just warming up, and there's no quiz today, right? Getting that brain ready for calculus 2018, right? Okay, we still haven't integrated, right? So now can we integrate?
Yeah.
What's the rule for e to anything? Just e to whatever, right? And we need the 1/2 in front. And don't forget the... Here we go. Now, how do I get y by itself? Multiply everything by 2. Can you see that if you multiply everything by 2, 2 times 1/2 just leaves me with e to the x squared? So again, how did I write down that line? Why did I write down that line? How did I get y by itself? Instead of dividing by 2, what did I do? And when I multiplied by 2, right? I don't need 2c to create a different constant. It can stay just c. What would you do next?
Square. Root it.
And if you like, you can, because technically they're different numbers, you can write this constant as c1, and then the next one can just be c. But we're not going to write down 2c. That just adds more work. Next, we're going to take the square root. Now, the only square root I'm going to write down is going to be the what? Y. Y coordinate is negative. The other one would be positive in front. We're not using that because the given point, the y coordinate is negative. Good. Now what am I going to do is I'm going to plug in. What number will I plug in for y? And what number will I plug in for x? And then I'm going to solve for the constant, the candy. What is e to the 0? Good. Keep going. How would I get c by itself? What number don't you see in front of the square root? So if you divide by -1, it's now positive 3. What would you do next? Square. It's already square root. Square. And 3 squared is? And then what's the last step? So what does c equal? That's not the answer yet. So what will the answer look like? Y equals, because the question was to find an equation, right? So now I can write down the equation. Well, what is it? Negative the square root of, I'm going from this right here, right? E to the x squared. Now I know what c is. It's 8, and it's done.
That's the equation of the curve.
That is the equation of the curve that has this derivative through this point. This is the derivative. This is the point. What equation would match that? So in other words, if I took the derivative of this, what would the answer be? And if I plugged in the 0, -3, it would be a point, right, on there. So the derivative matches and the point matches. And that's it. Turn the page. All right, let's start. If I'm finding a general solution, that means C is going to be my answer. What is step 1 to find the equation?
That's to put dy dx.
Is it already there? Yes. Step 1 done. Step 2. Let's do it. So multiply both sides by dx. Step 3. And the better you get, step 2 and 3 can be done in one step if you get better and better. Separate the, what does that mean? How do I get all the y's to one side? Nope. Divide by dy. Now, I don't like dy in the denominator. So instead of dividing by dy, you know what I'm going to divide by? Yeah, y minus 2. So I'm going to divide by y minus 2. And then to get the x's together, I'm going to divide by x. And I just made the y's on the left and the x's on the right, so you feel comfortable. So how did I get the y's together? I divided by y minus 2. How did I get the x's together? I divided by x. Now what? Just a side note, if it's 1 over y minus 2, right? Because that's ultimately what that means. How would I integrate that? I like it. So 1 over, what is the integration rule? Ln. Remember last question we took the derivative of the exponent to see the hook. This time we take the derivative of the denominator. What's the derivative of y minus 2? Just 1, right? Or dy if you like. So there's no hook in terms, it's ready to go. So in other words, if you take it, it's the absolute value, because I know you're going to forget that, of y minus 2. What is it on the other side?
Ln x, ln absolute value of x.
And? No, but keep it with the x. Be consistent with your structure. It'll be better. And if you add 1 on one side, it's a constant, right? And you're creating more work for yourself to go plus c and plus c on the other side, because technically you'd have to create 2 different variables, and it's a headache you don't need. It's a constant that you're adding. You could combine like terms and make another constant. They're just a number that we're going to find at the end. All right, how do I get y by itself? How do I solve for y there? What undoes ln? What undoes a logarithm? An exponential. So how do I write this exponentially? You ready? I'm going to take out because I'm going to run out of space here. How do I write this? So, do you notice we have 2 logarithms? We have to pick one of them. I want to get y by itself, so that's the one I'm going to pick. What's inside the logarithm? The absolute value of y minus 2. If I'm going to write it exponentially, what's the base you don't see for ln? No, what base? When you see ln, what base don't you see that's there? E. And then what's the exponent that goes on E? It's the skill, algebra skill. Can you write a logarithm as an exponent? Can you write an exponent as a logarithm? That was last unit. That's okay, you'll get time to practice. So how did I go from one step to the next? To undo a logarithm, you write it as an exponent, right? Next. So do you see the E and the ln? Yes or no?
Yeah.
So what? They undo, right?
Yeah.
So what can I write down? Just the absolute value of x. What do we still have right here? So one of the exponent rules are that if you're adding, I can separate that by multiplying. So in other words, I could write this as e to the ln x times e to the c. They're equivalent, because when you multiply and the base is the same, what can you do with the exponents? Add them. Can you see that algebra?
Yeah.
So I simplified the left one and I left the right one alone. I'm going to tell you this right one, e to the c, is just a constant, not a variable, not anything else. So in other words, originally we had one constant, and I can call that c1, whatever that number is. Now, what I'm going to do is I'm going to relabel this. In e to the c1, I'm going to relabel it as just a constant. So instead of c1, I'm just going to call this whole thing just c. I'm trying to make my life simpler algebraically going down. It's just a number, whatever it is. I can redefine that number. So in other words, whatever number I get for c is the same as e to the c1. So in other words, I can put c here in front. Now, I need to be able to remove the bars. Do you know that? And you know, what does absolute value do? If it's a positive number or if it's a negative number, right? You're going to get the same positive answer, right? On the right. So to undo the bars, the answer on the right could actually be positive or negative, just like a quadratic, because the absolute value of a positive number or the absolute value of a negative number will actually give you the same answer. So that means there are two solutions here, one that's positive and one that's negative.
But they both end up to be a positive number, right?
When you plug it in, it will eventually, right? But that constant can be either positive or negative. One last step. How would I get C by itself? Or Y by itself? And one of the challenges is that you can rename these constants. So if you want, you could rename this C2 instead of C1. If you wanted to. That plus or minus could just be a constant in front. When would that constant be positive? It's when the y coordinate is positive, right? And when would it be negative, right? In terms of it. It's the algebra here, right? In terms of getting it by itself. And the practice to go with it. B. Do you notice B uses the same differential equation, but this time it gives you a point. If it's y at 1 equals 1/2, what point is that? 1 and 1/2. Remember I said that was the general solution that we came up with from the last question? What number would I plug in for y and which for x? When I solve for C, it'll be obvious if C is positive or negative when I solve for it. So what number will I put in for y? 1/2. And what number will I put in for x? 1. And now solve it. So C times 1 is C. Subtract 2. What does C equal? You can go negative 3 over 2. You could tell me it's negative 1 and a half. All of that is beautiful. So what's the particular solution? Y equals negative 3 over 2 x plus 2. What does that mean? If I took the derivative, what would it match? Right? If I plug in the point 1 and 1/2, it would be on there. So you're given the derivative. Can you integrate and tell me the equation it comes from? And if you're given a point, then you can plug in and figure out what C is. It's a little different way of thinking of the calculus here. So we're going to practice together first. But there is the 8.1. Mr. G Math, over and out. Diffie Qs.